Hey, 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 Happy New Year, everyone. Robert, you still mute.
There, all better. All right. Hey, Happy New Year, Alessandro. Cheers, buddy.
Cheers. I'm so happy. We're back. It's the first show of 2021. I didn't think I was going to say 2021 very soon, but it's already here. I'm excited. I mean, this is going to be an awesome year. And we've got a present for all of you watching today. So before getting into the episode, and by the way, we should say what the episode is. Today, we're lucky to have with us NGD Systems. So we're going to talk about computational storage with the NGD Systems team. I'm really excited for this show. It's going to be super interesting. There's a lot that I need to learn about computational storage as well. So I'm excited to hear everything about computational storage. But before doing that, Robert, we've got a surprise for the audience, right? What do we want to do?
We want to break down 2020 because 2020 was, as you know, a great year considering the circumstances with, of course, COVID and all the lockdowns. We still had an amazing year, I think. And I mean, not to downplay everything else. I think that there was a lot of cool things that happened. And so I'm really happy to kind of share some of the landmarks or milestones that we had with this show and everything else around ARM in 2020. So yeah, let's do that first, right? Before we bring in our guests.
Yeah. Who starts? Should
you.
I start? Awesome. So, I mean, yeah, it was really, as everybody knows, we all lived through this weird times where everything became digital, right? Like all of a sudden, everyone was online and we couldn't meet anymore. Like me and Robert used to travel a lot for work and we had to stop. Everybody, I think a lot of people watching were probably traveling a lot as well. So we all had to stop and we had to really think, what can we do together as a community? And I think, all in all, I think we did a pretty good job. So I was keen to showcase a couple of the things that we, or at least, point out a couple of the things that we did. While I was looking back, it was quite interesting to see all the really, really cool things from the community. So without further ado, the first thing I wanted to bring up was actually the work that the ARM developer community actually did around a really cool project called Rosetta at Home. So this is a project that actually was driven by one of the a university in the US, and it was all around trying to really kind of share the load by running different calculations to understand everything about a protein and how it couples and how it builds itself across different computers. So what you could do is actually run this on your own desktop. And what was interesting is actually the effort that the community did to port all the Rosetta at Home to client to actually run on ARM, right? So there was a lot of work gone in by a lot of different people. And it was a pleasure to see that happening. Did you have a comment, Robert?
I did actually. I think that this is a perfect example of ARM developers stepping up. I think it was just an amazing thing to see. Of course, the world is in disarray. So many things are happening. And then here you see developers, rallying together and just showing what they're made of to basically enable this all on ARM. And I mean, since then, I believe now there's over 6,000 ARM devices running something like that are running Rosetta. They're still running. So they're still, crunching proteins. They're still figuring out, so much helping. It's basically a decentralized supercomputer, right? And I thought that was just amazing. So definitely a cool thing.
And the whole thing is made so that it helps with diagnostics. Really, that's the whole point of the compute. That's what it's doing. COVID-19 diagnostic, actually. So that was super cool to see, and it was a pleasure to be a part of it. The second thing I wanted to point out was actually a big project that a lot of different companies participated in. That was run by Hackster. Or on Hackster. It was around a UN development program to actually help with detection and protection of people around COVID again. So it was again another interesting project that the community kind of rallied around, and they developed, a lot of people developed a lot of really interesting projects to help with detection and protection against COVID-19. This was actually done right at the beginning, so it was interesting to see all the effort that went in from all these different people. Yeah, so that was two really cool projects that we saw right at the beginning, actually. And then we did something really cool in October, actually, was it, Robert?
It's October, yeah, beginning of October, ARM Dev Summit. So yes, an amazing event. I'll let you kind of go through the nuts and bolts of ARM Dev Summit, but I mean, in general, like everyone was switching, like Alessandro said, everyone was switching to this virtual platform. And I mean, this comes with its own difficulties, right? Everyone's used to traveling. They're used to seeing people in person. They're used to these hallway tracks where, of course, I can go to a session, I can go to a keynote, and I still feel, me personally even, that a lot of business and a lot of communication happens, networking in the hallway track, in between your sessions. And I think that that's just something that ARM did very well. So when we launched the ARM Dev Summit in October, we had just so much stuff. And Alessandro, I'll let you kind of do the breakdown here, but I mean, I was thoroughly impressed. And I did a lot of virtual events last year. ARM Dev Summit, I think, took the cake when it came to virtual events. They did a really good job.
Yeah, I mean, it was our first, actually, our first developer summit for ARM, right? So this was it was a massive feat, and it was virtual on top of being the first event. So it was really, really a lot of work, and a lot of teams worked together to actually achieve a great result. There was about 10,000, over 10,000 people actually registered to the event. We had 8 tech tracks with 92 sessions. And actually what's really cool is you could find all these sessions online on YouTube. So if you haven't watched them yet, they're all still available for you to watch. There's a lot of really interesting sessions from a lot of different people in a lot of different tracks. So 8 tech tracks.
On this channel.
On this channel, yes, exactly.
Yeah, on this channel, yeah.
And then, there was 10 workshops where we actually run things for, I think it was about 2 or 3 hour workshops that were actually hands-on with a lot of participants actually building stuff. Then we had 30 ecosystem talks, innovation talks, office hours, sponsor sessions, a lot of sessions. And most of these, again, you can find them on our YouTube. And the last thing I would say is, I think I've said everything. That's all. I was looking through my notes. I think, I've covered most of the highlights. It was a really cool event, and it was it was fun to actually be able to watch all these things. I think one positive note on all this is, because everything is online, you can actually rewatch stuff. So we were very busy on trying to get stuff kind of underway and working things out. But actually, I managed to watch a lot of sessions after the event, right? Because they're all recorded. So I think that's a really good positive note of having everything online.
I'm like watching myself right now. I feel super off balance with you. Like you're so centered and right there in the screen, and I'm like down low, not centered. Anyways, yeah. So yeah, Dev Summit was amazing. Can't say what's going to happen this year, right? I mean, as Alessandro mentioned, this was the replacement for ARM TechCon, which ran for, I believe, 15 years. First developer-focused event, and I hope this year we have the same event, another developer-focused event, but in person. So we'll see what happens. No guarantees, obviously, but that would be my hope and dream. But yeah. So moving on. Sorry, Alessandro. Yeah, okay. Moving on, I think this is the last thing we wanted to update you on. And I want to let you all know, too, I will be releasing a blog. So, I mean, we're covering like 3 of these major topics, right? But there is a blog that's going to be going out with a big, long breakdown month by month of all the cool announcements that have happened in 2020, along with some of the other launches that we had. But with this last big topic here, we kind of adapted, right? So 2020, as Alessandro already mentioned, we adapted to this new virtual space. ARM developer before 2020 didn't really have ways to reach out to the developer ecosystem or the developer community. And, due to the hard work of Alessandro, his team, the people over in our team, my team, we were able to, and of course, social media teams at ARM, we were able to get some really cool channels launched. So, one of the first things we did right away, we were like, hey, we need a way to communicate with developers. What's the best way? Twitter. So there we go. We launched a Twitter channel. This was something that I think was a huge milestone for ARM developer because it allows us now, instead of looking at things from, I want to say, a more corporate lens, we're able to now kind of focus fire and look at developers as individuals, the things that they're building and creating on ARM. And so with Twitter, we're able to communicate, share, and engage with the developer ecosystem at a whole new level. So at ARM Software Dev is the handle. Just in the short amount of time, I think we launched in April or May. I think it was May actually. We're already almost pushing 2,000 followers. Everyone is super engaging and super wonderful on our Twitter channel, and we hope to continue to grow that and share amazing developer updates throughout the rest of this year now. So huge feat, amazing. Thank you everyone for participating and following us at ARM Software Dev. We hope to continue that. Now, you're watching us here on YouTube. Believe it or not, this YouTube channel is so new, right? This YouTube channel was launched in October. So this was launched in conjunction with the ARM Dev Summit. We did a 3-day event where we brought people kind of on like a post-game show. This kind of marks the milestone for us being able to do these live streams, to communicate with you in real time, participate with the community, and share amazing things like what we're going to be doing today with our folks, with our guests from NGD. So this is just a huge feat. Since then, we've gotten over 600 subscribers to the channel. I'm going to read some stats here. But we've gotten over 650 people to subscribe. We've had 1,845 comments. The videos have been shared over 320 times. We've gained over 100,000 views. People have hit the like button over 600 times. And I mean, it's just great, right? I mean, having you all here on a weekly basis for this live stream in particular, as well as being able to share things that are stapled in time, right? These videos that are created and don't just get lost into the ether or into the internet, never to be seen again. We have a place to now host them and keep them for a long time, as long as they're relevant for us to share with you, the developer ecosystem. So very cool. And I want to personally thank everyone who has participated in both our Twitter and our YouTube channels. The last thing here is Discord. Now, while this Discord server isn't ARM's Discord server, it is very heavily sponsored by ARM. So we have an amazing Discord server. We call it the developer ecosystem. And it is predominantly, I want to say 99.9% all about ARM. So you can find almost 2,000 developers in that server, people sharing things from AWS to blockchain to, of course, everything on ARM. Developing hardware, Linux, open source. There's pretty much a channel for just about everything. And there are some very seasoned developers in there, as well as some newbies who are there just trying to get their questions answered in real time. So Discord is definitely a cool place to be. And we have had a lot of fun growing that community as well. So huge thanks to everyone once again. And yeah, that's 2020 in a nutshell.
Yeah. And I wanted to say one last thing. I mean, we said all this not just because we want to, say that we're great and we did a lot of stuff. Actually,
I did a little bit.
Well, a little bit, but actually, all of this wouldn't be possible if it wasn't for you, right? Like all the stats that we said that we shared with you are actually possible because all of you watching, sharing, contributing, talking to us, and for me, the reason why I'm doing this is because I want to talk to you. I'm actually, I really want to hear what you're thinking about, what you think we should do more of or less of. So, I'm really happy that we're growing this community and we're doing it together. So, to everyone, Happy New Year. And, it's a great start. And I think it can only get better. So I'm really glad that we have with us some great guests. And I think it's probably time to bring everyone in. So Robert, are you ready?
I'm ready. Yes.
Cool. So let's bring in Vladimir and Scott from NGD. So Vladimir Alves, CTO of NGD, and Scott Shadle, VP of Marketing of NGD. Welcome to the show, guys.
Howdy, everybody. I apologize in advance. I already drank my coffee, so.
Mine's cold, so.
Thank you, Alessandro. Thank you, Robert. Yeah, happy to be here. Excited.
Awesome.
So we appreciate the opportunity to join you guys on this, the kickoff of 2021. The stats you guys just covered about what you guys accomplished in 2020 are awesome, especially in light of the COVID situations and stuff like that. As you can see, we're in various different locations as we participate in this, so this is great. We're doing a multi-continent effort, so it's kind of fun to be an exciting part of this and get a chance to introduce the folks in the ARM development industry around what we can do with some of these cool ARM cores that we've put into our devices that we're about to talk about.
Awesome. So I think first thing, as we usually do, I would like to give you kind of the floor to introduce yourselves. And what I'm interested in, we'll start with Vladimir, is actually to hear, we haven't talked about what you guys do yet, but, I want to hear about, how did you get to become the CTO of NGD Systems, and what brought you to develop, we're going to talk about computational storage, we're going to say what it is, but, what brought you to develop these awesome devices?
Sure. Yeah. So, I can say a few words about myself. And, I've been lucky to have been working with a group of people that really is the backbone of NGD that I've known for over 20 years. And we work together in different companies on and off, and some were straight away and come back and so on. And at some point we had a good opportunity back in 2013 to kind of chase a dream that we have to actually, go and develop our own, bring our own ideas to fruition, bringing them to reality, and develop new concepts that we've been thinking about, through our careers and so on. And basically, as we had been working together for many years in storage space, and storage devices are notoriously dumb, right? It's read, write, and erase. These are the three functions that you can perform there. So we always thought that there was an opportunity to do more, right? Because all the information ends up in a storage device. So that's why this concept came on and so on. And we started this company back, as I said, back in 2013. I'm one of the co-founders, but there's a core group that has been working together for a long time, and they are really the important people in the company, the ones that actually do the real stuff, right? That's in a nutshell.
Awesome. Thank you for sharing that, Vladimir.
No problem.
Scott, do you want to go next?
Absolutely. So a pleasure to meet you all. So a little bit about me. I've been in the industry a little over 25 years. I've had quite a few stints in storage. My goal has always been to have fun bringing new technologies to market. I spent a lot of time at a small company now, called Micron Technology for about 15 years, brought technology to market there as an engineering individual. And then I took the frontal lobotomy and became a marketing guy. So now I get to talk about it instead of build it. One of the things that's been great about the working efforts with Vladimir and the team here is we've got a long history of bringing new products to market in innovative and new ways. And so I joined NGD Systems a few years ago to kind of help bring it to bear, if you will. And we had some fun. And for all of those on the line that are developers and always curious about where these three-letter acronyms come from, NGD Systems has a unique title that we use internally to the company. We actually made stickers. As you can see, we call ourselves a bunch of nerds, geeks, and dorks. So that's what NGD System stands for, in case you're wondering. And if you'd like a cool little sticker, I'll be happy to send you one if you let us know how to get a hold of you. Ping me on DM on Twitter or something. But I had those made because it just helps people realize that we're just having a lot of fun doing really cool new architectures and technology. And I love talking about it and bringing all this stuff to market. So a great opportunity. ARM's been a pleasure to work with. We've got a lot of cool stuff that we're going to be able to show you as we move forward. So again, I'm the marketing guy. I like to talk a lot, so I'll shut up so other people can spend some time talking as well.
Is that the real acronym though? NGD?
No.
The company started out as classified information.
Okay.
Officially, it is the C.
Yeah,
Next Generation Data Systems is officially what it stood for. But everybody's like, what does NGD stand for? And it's just fun to make up the acronyms for it. So I made stickers and people love them. So I'll send them out to anybody who wants one. Awesome.
Cool.
Awesome. Cool. So we're all here to talk about storage, but actually kind of the next generation of storage, right? Storage devices called computational storage. Look, you're ready. You're prepared. So
Yeah.
Before getting into what you guys do, I just wanted to kind of give a really, really high level overview of what it is. We talked before in other streams, in other shows about the concept of computation on the edge, right? And this is kind of like that to the extreme, right? So we're talking about really a computational storage device is a device that is capable of doing computation on the actual storage device itself. So if you imagine, an example. The storage device, dumb. Vladimir, you mentioned it before. Usually, storage devices were dumb, right? Like they were just storing data. If you manage to actually, so what you used to do is, you have to ask the device for data. You bring it to a cloud, then you do processing there, then you send the answer back. With computational storage, what you can do is you can request for an operation to be done on the device itself. So you do a request for an operation. The device operates with obviously a processor on the storage device itself, and then returns back the actual answer to that operation, right? So if you think of that, what it means is really you can do that in parallel on a lot of different drives at the same time, right? And you don't have to basically go back and forth between the cloud and the device itself. So I think it's one of those things that sounds simple, and it sounds like, why have we not done this before? And actually, that's a question I have for you guys in a few minutes. But it really it's something that sounds very straightforward, right? It's something everybody should do, but actually it's a new thing. And I'm really keen to hear your view on what computational storage is and what it enables.
Got it. Great. Scott, you want to start and then I take over? You're muted.
The double secret mute. Sorry. So to your point, exactly what you're saying, Alessandro. The big thing is it took time for the industry to get to a point where this type of technology really adds the extreme value that we're looking for. So it's not, quote, brand new. This concept has been around for some time, and I've worked on it previously in other ways and aspects of it. But we're generating so much data, and everybody wants to bring in all that data. Nobody wants to move it. It's the concept that if I were to fill the house full of all kinds of stored material and everything like that, and I want the one picture in the box in the back corner, how do I get to it? I have to physically move everything around to get the one picture. And so the concepts that we've put together for computational storage is, instead of having to go dig for the picture, have a tool that actually goes and finds it for you. So we've become effectively kind of like the concept of the pod system for storage. Bring it to you and store it somewhere else, and only move the pieces that you really want, not all of that data. And so that's the genesis behind what we do. And then it's a matter of putting it in an architecture that allows developers like those on the line to be able to use it in a very efficient fashion. If it's not seamless, easy to use, and plug and play, if you will, it becomes much more challenging to deploy really new architectures, as you kind of highlighted with some of the stats you mentioned previously. So.
Yeah, so I can add a little bit of clarification there in the sense that fundamentally computational storage has to do with two basic concepts that have been explored over the ages in computer science. One is near data processing, the other one is distributed processing, right? So why near data processing? Because it's been known to bring advantages in the fact that it reduces the movement of data. The fact that you can, extract information from data without having to move data around, right? And that's something that we are doing with computational storage. So why hasn't it been done before? In a way, it has been studied before. There are several papers that we have seen over the years that explore how can near data storage be applied to storage devices, storage systems, storage appliances, right? But it's something that needs to be matured. And from the moment the storage starts to the moment that real implementations are out in the field, it takes sometimes many decades depending on the topic. So this is the case for computational storage, and we had been following that. As you said, since the beginning, we were frustrated with the fact that storage devices are basically dumb. They can do read, write, and erase. So why not add more? And actually, the industry had been doing this kind of stuff by, for example, adding encryption capabilities to storage devices. This is something that exists for quite a while now. And even though it's a very complex processing kind of function, but it's really simple, right? So, okay, either I encrypt or I do not encrypt, and I can choose between a bunch of keys and do maybe a little bit of key management, and that's it. But so the question was always in our mind, why not more? Why can't I do like a complex search? Why can't I, do things that are much more sophisticated that can be then offloaded and done at the device level, the storage device, rather than at the CPU level? So the other thing that helped bring this to fruition is the evolution of the chip design manufacturing nodes, right? So we're down to below 10 nanometer technologies today, and so on. Our controller was designed in a 14 nanometer technology. I think it's one of the most advanced SSD controllers in terms of manufacturing a processing node. So this enables us to kind of pack more logic, more processing elements inside the chip and make it like viable. So 10 years ago, it would have been very hard to do. So there are several factors that can account for that.
Awesome. No, thank you for that. It's always great to hear, the answer from people that actually are working in the industry, have been in the industry for a long time, right? Working on this problem. So thank you for that. Thank you for sharing that.
And full disclaimer, we work with ARM. We love ARM. We use ARM technology. So let's put it out there.
How dare you?
So this feels a lot like edge compute. I mean, it is edge compute, right? I mean, at the end of the day.
Yeah, that's a really good way to look at it. Absolutely. I mean, if you think about it, what we're offering a customer is a server in a storage slot. Where that storage slot is going to be in an edge platform, it's going to be in a data center. It doesn't really matter. But we're offering an edge compute platform in the form of a storage device. So you get all the pleasantries of high capacity storage with the ability to do all the work you've ever wanted to on that storage.
So I think, Alessandro, I'm going to steal this question here. I think I want to hear about use cases. So, I mean, looking at like from a developer point of view, maybe even going into a more industrial point of view, how would developers use this? What are some of like the main use cases that people are kind of scooping these things up and using them for? And maybe we could start with, what would a developer use this for, all the way up to kind of like what would some corporate entity, big time business use this for?
Yeah, so let's say a couple of things and pass it on to Scott, because he knows how to talk about this kind of stuff very well. There's two aspects that we need to consider in terms of use cases. One is, where is our platform, our device is deployed, right? Where is it? Is it at the edge, in a gateway, in a satellite, right? Or in a data center? And the other thing is, the other aspect is what workload is running on that. Is it a machine learning workload, computer vision? Are we analyzing video? Are we doing searches? Or are we running a database, right? These are the two things that we need to look into. And it's not like a very simple answer, but I'll let Scott talk about some of the POCs that we ran there. Super interesting. He is very,
that's
excited
my job,
about
right?
this. Yeah, that's his job. Yeah.
So we've had an opportunity to work with a lot of unique platforms. And to your point, Robert, we've got edge customers and we've got data center customers. So we've done some recent work with Microsoft in the research division. We've actually written a paper with them, co-authored a technical paper on how to deploy AI and ML in a storage device with our technology. And it even does a comparison of what our product does versus some of the other solutions that may exist in the market. Because I do want to highlight for developers, there's always a problem with, if it's the only one, do I really want to go there? This technology is developing. We have our solution. There are some other solutions in the market. We definitely favor people wanting to use our product, of course. But overall, some of the solutions, we've done things like Elasticsearch. We've done deployment of MongoDB databases. We've done AI/ML training and inferencing. And then I also actually have a recorded demo that we did with the Microsoft Azure team related to IoT deployments. And I can actually, if you're interested, I'd be happy to show us a snapshot of that video clip, which we actually have a link that we can share as well to the full concept that we have going for that, and be able to kind of highlight what's available from a perspective of the products and technologies that we offer.
Alessandro, you're interested?
I'm ready.
Okay.
I'm going to share the. I'll bring it up. I'll share the link for everyone that's interested. That's the right link, right, Scott?
Absolutely, yeah. So what we're going to do here is, a lot of people wonder, can I use this product in a remote environment? What kind of host system do I need to actually work with this? One of the unique things about the Azure IoT Edge platform is we have a customer in Australia, telco, that wanted to create a surveillance platform where they brought incoming images through a USB camera and using Azure to actually do the machine learning piece of it. The problem they had is it needed to be a small footprint and a lightweight. So they used a Raspberry Pi to ingest the images and then use our device to actually talk to the Azure cloud and do all of that work. So what this quick 4-minute video talks about, let me turn that off. What we're going to do is we actually create an instance of an IoT hub out on the Azure cloud platform. And so this is us creating an instance where I can now go talk to the cloud. What's unique about this is we developed this particular module and agent and hub. Normal people would be deploying these on a host system. What we're actually going to do is convert this from an existing x86 runtime environment that you can see popped up here on the slide, and we're going to copy in the ARM-based deployment model. So this is where we're getting into not only using ARM on our side, but we're deploying ARM to ARM on Microsoft Azure as well. So the engineer that was running this is able to put that out there and create this hub and Azure platform out on the Azure cloud using an ARM, using our ARM to talk to it. So what we'll see here in just a second is they're going to copy these development strings. When I pause right here, you can see in the background, let's see if I can get it to pause. This side right here is showing root at node 1. This is actually within the device. This is the Linux OS. Our engineers actually real-time communicating with using a PowerShell to talk to the device, the Linux on the device. This over here is the actual server host platform. So as we go through the rest of this quick demo, you'll see that all the work is being done inside the controller on the storage device. All the host is doing is saving a picture to that storage device. So we're going to go through, I'll go ahead and skip ahead. You can see that the Edge Hub and Edge platform are actually running inside the storage device. The host is sitting idle. There's no work being done. So all this work is being actually accomplished by using the ARM controller inside our storage device, talking to the ARM instance on the Azure cloud itself. So then what we do is we create a computer vision application that is a tool and a module out on the Azure platform to actually allow us to take an image, send it to the cloud, get the cloud image back, and restore it on the device. So as this process goes through, you can see here that all of this setup was being done. Again, we're still on line 1 of the host. The host platform is not doing any work. All of it's being done over here. So we've got the image classification tool in a status mode. So what we're going to do now is actually engage the host, and we're going to save an image from the internet, if you will, into our storage device. We're going to go grab a picture of the Leaning Tower of Pisa. We're going to copy off that image, and we're going to stream it into the actual host drive. So now we're going to do some work on the host system. This could be a Raspberry Pi, it could be whatever platform you want. All I'm doing is moving a copy of that picture from the internet into the storage device on this side. And as soon as that image shows up, this image analyzer tool that's waiting to find information goes out, grabs the image, does the image analysis on it, and all of a sudden we now have ourselves a Leaning Tower of Pisa. So this is an example of using our internal ARM controller to do all of the leverage work, and all we're doing is storing a picture with the host platform. And now think about deploying this across an entire array of products in a local system, or going all the way out to a full data center of these types of products.
That's super cool. I mean, it's very interesting to see that happening. And actually, you know, it's really nice how you shared it, or how you showed it. The fact that you're showing, like, you know, in parallel the two machines, and you could see effectively that the host machine is not doing anything except
exactly
sending the image at some point.
And there's a full video that talks about the setup of everything and the actions out of it that's available on our website, which is the link that he put up on the screen. So if you want to see the whole thing and listen to me talk a little bit more, feel free to check that out. And if you have any questions, again, reach out to us on Twitter or directly on the website.
Well, while still on the topic, we did get a question in YouTube. So maybe you can actually answer this live. Jay Plexer asks, so that basically means that the storage device does the computing, well, the connection to Azure.
Absolutely. That's exactly what we're doing. Is the beauty is not only are we doing the compute on the storage device itself, but the storage device is communicating to the cloud, not the host. Mm-hmm. So the host is connected to the cloud, but the device is actually doing all of the communication itself. The host isn't talking to Azure, it's just allowing us the path to Azure. Because of course we don't have today an Ethernet attached device, which is something that's a roadmap item for us.
Yeah. And we're basically running a full-fledged OS. So it's a Linux kernel, and we can run different flavors, Debian, Ubuntu, whatever you want, basically inside the device. So you can connect to the appropriate mechanisms, and I'm going to talk a little bit about it later, how you connect.
That's cool. And just to reiterate what you said, Scott, it's actually arm on arm, right? Like you're actually running the. So this is something that, it's amazing to see in action, because it's something that probably a year ago was probably, I'm not sure about. I think a year ago was probably impossible, right, to see, or very hard to see, right? It's happening now. And it's super cool that you.
And when we originally recorded that demo, it was still a beta release on Azure to have ARM. So that's one of the reasons we had to actually do that conversion, and to convert it to the ARM, because we were one of the few platforms that were allowed access to the ARM development servers at Microsoft. So that's why we know this platform's solid and works. And the beauty of it is, that was an example of doing it on Azure. We can do the same thing on AWS Greengrass. So you need an edge-connected compute platform that also can store all of your images, and you don't have a lot of power or processing to do it with. Drop one of our drives in, and you're ready to sail.
Awesome, cool. So you talked about this use case. Is there any other use cases, as Robert mentioned earlier, that you wanted to bring up as kind of typical use cases that you're seeing in the market?
Yeah, we've got a few different deployments. One of the more fun ones that we've got going on right now is we have a customer who's doing the autonomous market, right? So the autonomous vehicle market, they put data recorders in the trunks of those. And I had the luxury of going to NVIDIA's live event last March before they shut everything down, where they were putting this massive GPU box in the trunk, and there was no trunk left to be able to make that car autonomous. The company we're working with has shrunk that to 1/3 its size, but they still need the processing power. But they don't have the power or the footprint for that massive GPU platform. So we've developed a data recorder with them where they use 4 of our drives to do some of that offload work in the car. Low power, high capacity, and compute offload. It's a win-win for that particular solution. So those are another example of kind of where we can take it and move it forward.
Looks like another question popped up on YouTube. We're going to pull that one up, Alessandro. We got it right here. So this is from one of our seasoned community members, iShot JR. He's here every week. Amazing guy. He says, just curious, could the same not be achieved with Lambda S3? What are the advantages, etc.?
Yeah, I can maybe comment on that quickly. Yes, everything that you do can be achieved with the other means, right? we were not in the case before computational storage arrived. What we do is enable NeoData processing. Basically, everything that you do now, you need to move data out of the storage device and push it into a bus, usually a PCIe bus, and then into a memory. That's when a host CPU can compute it, right? So this is a must today. So now what we enable is that, okay, depending on the use case, you can identify tasks or applications that, okay, makes more to run it closer to where the data is, and then bring the overall efficiency of the system up, and the energy efficiency, the computing efficiency. So I think the advantages are, when it's the right application, the right workload, it's higher performance because you are putting together the host CPU and ARMs that are located inside each drive to work together, and reduced energy consumption.
So I actually have I brought this up on many occasions. I mean, one of my specialties here at ARM with the developer evangelist role is focused on infrastructure, cloud native development, stuff like that. A lot of what we talk about is backhauling all this data, right? Like data is created at the edge, at the end device, and then it all gets backhauled up into the cloud, right? Yeah. Have any of you or any of your engineers run any benchmarks using your devices where, how much energy is actually saved? How much data is actually computed here that wasn't required to be sent up to the cloud?
It depends a lot on the workload. It varies enormously. The paper that we co-wrote with some partners in the academia and at Microsoft Research talks a little bit about that and drills it down for a few applications that are mostly oriented towards computer vision. And we see, it varies to 40, 50% down to, 4 or 5x. It depends a lot, right? So it depends on the workload itself, the amount of data that we're talking about, and how far you need to move it, and so on. It's hard to proper engineering answer, but marketing has a field day with this kind of stuff. They say, So yeah, it's something that it's something that I would say that anybody operating at the edge should look into it and see how much advantage they can get.
I noticed you just shared something in our chat, Scott. Do you want us to post that?
Yeah, if you want. If you mentioned the research paper, so that's the link to the journal platform that is supporting this. It's the Association of Computing and Memory. That's where that paper was published. It is a firewalled platform, so I do apologize for that. I can't control that. If you're interested in some snippets from it or some kind of like the table or overview of it, certainly, again, back to the whole DM me and I'll be able to share a little more of it for you if you're not able to actually access it as a member.
Cool. I think Robert, you brought up the fact that, and we talked about it briefly earlier, the fact that, these devices are running Linux, right? And there's a whole suite of development environments that you can, or development tools that you can use. So actually, we have another guest with us today, right? You guys brought one of your colleagues, Hermes. So I think it's probably time to bring him in and actually have him speak a bit to the kind of developer flow and what it looks like from a developer point of view, right? Yeah. So if you guys are happy with that, I'll bring Hermes in from the green room. So hi, Hermes.
Hello.
Hello.
So he's the lucky guy that you get to hear that gets to play with this and paid to play with it. So
yeah, nice to have you on the show. Thank you for joining us.
Thanks for having me.
You in the background for a little bit. But no, I'm keen. So I guess I just, as usual, just a few words on yourself. Feel free to introduce yourself, and then we'll fire away our questions.
Sure. I'm a electronic engineer. That's my background. During my career, I worked with. I end up going more to software development than actually circuits, and I've been working with software for a long time now. And since 2017, I joined NGD. So I had friends working there at that time, and they invited me. I was looking for an opportunity. They invited me to join the group. It was a really small group, very happy, familiar group, and it's been a lot of fun since then. And basically, I came to the team to develop the embedded system software. So the software platform, we started from scratch basically. And the decision was, okay, we need something that is easy to build upon. It's free, open, so you don't have to go purchase a software or an SDK or anything like that. So so we decided to go for Linux systems, and the decision for ARM processor was already done. So when I came to the group, the platform was already, the hardware was already there. And since then we came up with the platform. So it's basically an embedded Linux running on ARM 64 bits. And we try to make everything as open as possible. So we try not to change anything. So our Linux kernel there is a proprietary driver, of course, for our storage drive. But apart from that, everything is the basic Linux kernel. So we have a platform that's open. It's basically whatever solution you have running, you can port to our platform, and that's it.
Awesome. And I mean, it's really interesting. I think I see more and more people actually moving from kind of electronics to software lately, right? I think it's a trend that's growing, and actually that's what happened with myself as well. I started off as a electronic engineer, and then I was actually developing Verilog code, right? So I was writing RTL, and then I moved to software. It's always interesting to see that trend, and I think you bring along a lot of knowledge of I think knowing the hardware actually makes you write better software. So I think it's an interesting path. I know that you've got quite a lot of stuff to show us as well. So I don't know if there's any other comments or anything from YouTube. Otherwise,
can I ask a question?
Yeah, go ahead.
So you mentioned, Hermes, you mentioned how you're using an open source distribution, and in fact, Jay Plexer kind of in YouTube kind of is slightly echoing the question I wanted to ask. But so you have a Linux distribution. You mentioned proprietary components. I've noticed, a lot of this hardware gets put out into the ecosystem, and then of course, like you just said, then you need some SDK that you're going to pay $1,000 a year to use, et cetera, et cetera. Mad respect. I think that's awesome that you're opening all of this. I'm just curious, kind of as Jay Plexer said, is this a custom distribution? Can you just take a flavor of Linux, any flavor? Can you put Fedora on there? Can you put Ubuntu on there? Is this custom? Maybe you could touch on that. Also, looking at the kernel, are you just using upstream kernel, or are you, adding any patches to it? Or, maybe you could touch on that.
Sure. Yes, there's patches. It's an upstream Linux kernel. There are patches. Like I said, the only there's two things that we had to add to Linux to make our platform work, right? So our hardware is an ARM 64 core, but we had to make that core see the storage, right? So the flash, we had to write that driver. And the communication part, so the way we use to create a channel, a TCP channel between the hosts and the embedded system is also proprietary. So there's two pieces of software that we added to Linux, but without, let's say, changing anything in Linux. So we added stuff to the Linux. So there's a little bit of patches that you have to apply to the Linux kernel, and there's some pieces of software that you have to run on your host system to create that communication channel. But apart from that, there's no changes. It's a upstream Linux kernel. And the distribution, we are using off-the-shelf Linux distribution. So we use either Debian or Ubuntu, but we could use Fedora. You could use Red Hat, anything you would like. I guess we could make it work. There's no, because the way we created the system, the root file system and the Linux are independent. So you can build your own root file system and play with that. So you can change the distribution, the flavor of Linux, create your own using Yocto or something like that, which is something that we started doing. So at the beginning, we were creating our own flavor of Linux, and then we said, you know what? There's companies doing that for us, like maintaining Linux distribution. Why should we bother? So we just picked one up, and we're using either Debian, Ubuntu.
Yeah,
As Isaac. Oh,
Yeah,
sorry.
many changes.
Just a quick comment. Obviously, we follow closely what the work that Linaro is doing. Obviously in partnership with ARM, because obviously it needs to run on ARM. Basically, that's the requirement, right? So we've worked with Linaro quite a few times already in the past.
I used to work at Linaro.
Oh, great! Yeah.
Yeah. I was working for the 96 boards program. Yeah, I mean, as Isaac Newton said, right? Like, I've not seen further, and I stood on the shoulders of giants. I butchered that quote, but I mean, like, there's so much money that's gone into open source, right? Like, why not leverage it? And I think I think it's huge for any company to find a way to make money out of open source tools and code. So yeah, that's awesome.
Well, and just as a preview of what's coming, we've actually been working with a third partner of both of ours in the way of VMware. So we've got a project in the works right now with what they call their XLab solution in the office of the CTO. We've deployed a VMware deployment on our ARM controllers inside our devices. But the beauty is something called ARM was just recently released for ESXi for VMware as well. And we're about to do work with them to port ESXi into our device. So coming soon, you'll actually be able to run VMware ESXi as a root file system inside of our device, not just a Linux OS or anything like that. So for those people that like the virtualized environments, complements of ARM and VMware getting together and finalizing that last year, we now kicked off the program to do that inside our devices too. So that's a fun development way.
We just had Andre Workington, one of the leads over there with the ESXi Fling that went out. Yep. ESXi and ARM Fling. He was just on the show I saw that.
Yeah. So he's actually one of the guys that's going to be involved in doing that work. So
awesome. He's also one of our
how well we're tied in together with everything that you guys are doing in the development world. And to kind of give back to that, is it a custom or not? No, we're going full-fledged, standard off the shelf, keep it easy. The new KISS principle, right? Keep it simple and easy. Keep it simple, stupid, right?
Yeah.
Simple and seamless. That's what I meant to say. Sorry. Simple and seamless. There, I got it. Nothing like real time to make you screw up how you say stuff. So if you'd like to learn about that, we do have that out on our YouTube site as well. The VMware project was actually done at VMworld 2020, and we can provide the link for that as well.
Cool, and that's actually a good point to share the YouTube. So this is your NGD YouTube link. So if you want to hear about that or other things that the NGD team are doing, go to this link down here. Awesome. So we'll share everything as usual. We'll share everything in the comments afterwards as well, so you'll be able to look at it later. But I think I'm keen to see the Hermes, the work that you've done live, the live demo. I mean, let's pray to the demo gods while you get it ready.
Well, I did the canned one because I'm marketing. He's the engineer who's going to try to get it to show you some real time work. So I look forward to it.
Yeah, if the glitch something is good.
Yeah, so I'm going to show you guys a live system and show how it works, how we manage it, and hopefully I'm going to deploy a demo application that we have that is that uses TensorFlow to analyze images and get license plates from images. Okay, let me share.
Yeah, so as you share it, I'll bring it up on the screen as well.
Yeah, well, Hermes is sharing and so on. The application that he's going to use, I believe it's Kubernetes, right?
Exactly.
Yeah. So
here we go.
We basically, yeah.
Okay. So this is my host machine. It's a X x86 machine running Linux. Okay, so if I show here the storage I have in my system, the last one here, it's an NVMe drive with 2 partitions, right? And I have 7 terabytes of data available here. That's my computational storage. That's our M.2 SSD. You can see there's 2 partitions. One is mounted as MNT cluster 0. So if you look at MNT cluster 0, there's nothing there. I'm going to create a file there. So you can see there's a file there now. And like I said, we have this tunneling between the host system and the embedded system running in the computational storage, right? So these are my network interfaces. So there's a Ethernet interface here. This is my loopback interface, and this is a tap interface. That's a virtual interface created in my host system, and it emulates an Ethernet connection between my computational storage and my host system. There's no cable, there's no physical interface. It's a virtual connection, and all communication passes through my NVMe stack. And if I SSH to instead of node 1, let me use 10.1.1.2. You can see that my interface has the IP 10.1.1.1. So 10.1.1.2 is my computational storage. So now I'm inside my Linux running in my ARM core. So you can see it's an ARM 64 running Linux. And if you look at the storages I have here, I have one storage device called NGD BLK, and there's 2 partitions, right? A 4.8 terabyte partition and 1 terabyte partition. It's the same we see here on the host. So everything you see on the host side, you see also in the device side. Okay, and if you look what's inside here, see my file there. And if I remove this file from inside my sorry, roots for that. Now if I go back to my host system, the file is gone. For that to work, of course, both the host side and the embedded Linux have access to the same raw storage data, right? But in this case, I have a file system there that's shared between the host and the device. And for that to work, we are using a cluster file system called OCFS2, which is a Oracle file system. So therefore, I can use the same physical file system at the same time on both sides, and it works.
So again, just a quick comment. We're not trying to reinvent the wheel. We're using, common solutions such as cluster file systems or distributed file systems that have been, developed and tested to the yin yang before we started using it.
Yeah, and we also made GFS work, which is another cluster file system. I guess it's Google, not sure. It also works.
Correct, yeah.
Yeah. And now I'm gonna create a Kubernetes deployment. So from my host, I'm gonna deploy a pod in my embedded system, but I could be doing that from anywhere in my cloud, right? So I could be sitting in my office and deploy a pod in any storage device anywhere, right? As long as I have connectivity. In this case, my server, my Kubernetes server is going to be my host, but it could be anywhere.
So this is a very important component. When we started talking and presenting computational storage, people understood the concept of, oh, this is great and so on, but really, how can you manage, deploy applications on hundreds or thousands of drives and so on? And then we say, well, hopefully we can build upon we use the software stack that we have to build and for Docker container, and then from that point on we can take advantage, for example, as a possible way of deploying applications. And here we are. Hermes was one of the instrumental guys in getting it to work.
So I started my K3s on the host. It's my master node, and I'm going to start the agent on the embedded Linux. First, I need to set up the token.
While you do that, Hermes, I'm just going to quickly say to everyone, we're running a bit over. So if anyone wants to leave, we're gonna have obviously everything on YouTube. It's going to be available afterwards, so you can watch the end of the demo afterwards on YouTube and get a link to all the resources afterwards as well. So if you're leaving now, thank you for joining. Otherwise, we'll be another few minutes so we can see the end of this demo.
Yeah. Appreciate everyone's participation and listening through and all that kind of fun stuff. This is the part where I get lost myself, so I'm excited to learn some of this stuff too. As the marketing guy, the code stuff gets over my head a lot of the time. So hopefully you're all enjoying the code because he's amazing at it.
So continuing here, I just started the agent node. I can see it's ready. Both nodes are ready. I'm going to deploy my pod here. So my image is a Docker image, and it's stored in the Docker Hub. So again, I could be deploying this anywhere, from anywhere. So let me see pod's running. Looks like it's running. And I'm going to create my service. So now this is my problem. I don't have access to the network 10.1.1.2. So I'm going to try to create my service on the external IP.
And if find a few words while Hermes is typing away, basically developing our own brand storage for us was to create a seamless programming model, right? That was something that Scott highlighted, and allow pros out there tools and the environments that they're familiar with. So if you are, as a programmer, using high-level programming languages such as Python, you use Docker to develop and deploy your applications, you use Kubernetes to manage and deploy applications, then you can take advantage of all of that, right? You won't feel that you're doing anything different. Well, very similar to what you're doing. Well,
and that's a very interesting point, right? Like, that what fascinated me when I started to hear about computational storage is the fact that this is not a new world, right? Even though the technology might be, something new, but actually the way developers can access it and can use it and build stuff with it is actually nothing new, right? It's just reusing some of the programming approaches that they're already using in cloud native type development, right? So
exactly.
It's cool for that.
Yeah, and for it was a very strong, because it's very hard to get traction on a very new technology. So if we added a complicated or different programming model on top of all the modifications and novelty that we're adding, that would make it very challenging for adoption.
Cool. Hermes, we lost the screen. Did you?
Yeah, so I finished the deployment, but unfortunately I cannot access that IP address. So I cannot show you the application running, but I have it on
we believe you. I mean, that's it's a last step. We trust you.
We'll be able to get he's got a recorded version of it. We'll get around to getting that posted to our YouTube site. So if you track our YouTube site, you'll be able to see that get posted in a little while once we get it in a format that we can drop it out there. So
yeah, let's put the YouTube site up there one more time. So another question here, and I know we have to maybe go soon, but are you hosting any of these kind of like demos anywhere? Is there a GitHub or a repository that someone can, go at least test or recreate or have some fun, trying some of this stuff out? Is there developer documentation on your site, or is that not up yet or not going to happen? I don't know.
Well, we were working on getting something put together pre-COVID, and then all of our resources that we had put together to have that dev platform for people to log into turned into customer POC platform, because we host it all now here, since they're not allowed in their labs for the last year. So we will be working to get to a point of that right now. Unfortunately, today we don't have something you can just log into and jump on right at the moment. But it is something we do have as a roadmap item as we expand that POC lab, if you will. But we've got, if you're interested in more documentation on exactly how to use the tech, we do have some user manuals and information and things like that that are available if you guys reach out to us.
It'd be interesting to oh, sorry, Alessandro.
No, go ahead.
I was gonna say, it'd be interesting to possibly, we have the ARM developer website, and, NGD systems might be a good solution there for developers. If you have enough developer content, maybe we can feature you up there as well and forward people out to the stuff that you have going on. So discussion offline might be merited.
Yeah. I just wanted to point out also that we wanted to show the actual, because we've talked about the solution, but we haven't actually showed what the solution is, right? So we unfortunately ran out of time because we had a lot to talk about. But I mean, I guess, we have to show it at least, right? So there you go.
These are the small ones. So we have an M.2 and we have an EDSFF. And then we also have your traditional, like what would be a 2.5-inch drive form factor. So that is the actual storage devices you plug into the servers and the platforms for use in deployments in different types of systems. And if you need the smaller, more portable embedded stuff, like we're talking about the edge, that's where these new E1S and M.2 form factors come from. And I posted in the comments section, someone asked what we have, and I listed the form factors and the max capacities available for each of those as one of the comments as well. And our technology site link that we have, there you go, it also has some details on that. So just ngdsystems.com, you can find out all you're looking for. But very high density, very fast, very low power solutions that offer the compute from ARM.
Awesome. I mean, that was a really good summary. You did really well there. probably below a minute, and you actually explained what you have. So awesome. I can tell you're a good marketing guy. But no, seriously, I think I wanted to get into the depth of the actual hardware, but I was also going to talk about the software and the programming model. So unfortunately, we didn't do everything, but you have a website that people can access and have a look at different solutions. And are there solutions available now, shipping now that the people can get access? I mean, is there any last words that you want to say on that?
Sure. All of the hardware platforms that I just showed and talked about are available for purchase and use today. We do have capabilities to do all kinds of different deployments. We even offer a server-based platform if you want to buy it all in one and ready to go type of thing, where we can deliver it as a development system. So all those are there. And I think the primary focus here was to highlight that this is not just a new SSD. It is an SSD. Hardware's not cool, but the software that we've deployed on it and the ability to leverage the software deployment into the device is why we spent so much time on that today. So yes, we do sell a physical product, but at the end of the day, it's really what we're doing with that in the way of the software deployment and efforts that really drives home the value of this technology. Yeah,
agreed. And that's kind of the point of spending a lot of time on showing the use cases and the ease of deployment, right? And I think that's the power. I wanted to do a really short shameless plug for myself or for us, I guess. We have a white paper out that you can access through this link that actually talks about computational storage, all the latest and greatest ideas around computational storage that we developed, that ARM developed. And another thing I wanted to mention is that last September, actually 2020, we released a new IP actually called ARM Cortex R82. This is a real-time core that actually is going to enable the next generation computational storage devices out there. Obviously, as everything we release, it takes a bunch of quite a bit of time to actually get into the market with actual silicon and for actually having partners like NGD develop things around it. So it will be a few years from now probably, but this is it's an awesome new world, and I'm excited to see what's going to come out in this computational storage space.
Absolutely. So we're very happy to be a partner with ARM on it, and the technology that ARM offers that we've used in this controller is really what helps make it viable for us. So it's been a great working relationship and a great way to move the whole concepts of technology forward and just showcase that innovation is a partnership. It's not just a one-off. It doesn't matter how big or how small you are. You need to make sure that you're working with the right people to get things done.
Yeah, I just want to echo that. I mean, we've talked about a lot of people today, a lot of companies today, right? And a lot of partnerships that you guys have and we have as well. And it's awesome to see when everything comes together, right? So we talked about VMware, Microsoft, all sorts of different partners that have been working with you guys. And it's cool to see everything work well together, right? So I'm excited. Last shameless plug to you guys, if you've got anything that you want to kind of put out there.
I would just say that this isn't a one-off. This isn't a technology that's going to just come and be like a flash in the pan that they have in the past. There's industry standards bodies, SNIA.org and NVMe.org that are now driving standardization work around this. So as Hermes mentioned, there's a custom driver today. As we get into the next year or so, there's going to be public drivers available because of that work. And there's currently a little over 295 people in one of the working groups representing 52 companies. So this is a technology that is finally ready for the market and I'm going to drive it forward. And if you want any details on any of that and how that works, let me know. I happen to sit on the board of one of those two committees, so happy to help.
Awesome.
Very nice.
Cool. Any last word from anyone else?
No,
yeah. Oh, sorry. Please, Vladimir.
No, just wanted to say, thank you guys for hosting. All your audience and get them, to know more about computational storage and get excited through our website or even through you guys to get information. To know how to use computational storage. There's a lot of stuff that we do that's open with science, deep startup, happy and proud to be developing new technology, and happy to engage with new customers that are interested in general.
Awesome. Cool. What's the best way, Scott, Vladimir, what's the best way to get in touch with you if there's anyone interested in knowing more?
Our website has a contact us form. You've got my Twitter handle available right here as part of my thing here. Just DM me or reach out. Happy to help from that perspective. Real easy, info@ngdsystems.com is an email address that can get you to anybody within the company. So
awesome. Yeah, so last thing for me, I just want to thank everyone, Scott, Vladimir, Hermes, just amazing. Thank you so much for taking the time out of your day to join us on the show. Cheers to you all. Innovation and coffee. Yeah. I'll look the camera in the eyes here. Everyone who's watching, thank you all for your time. We did go over. Hopefully you appreciated the demo and all this cool stuff that's going on. Welcome to 2021. We'll be back next week, every week from now on. And if you aren't already subscribed to this channel, please click the subscribe button. Thumbs up the video. Thumbs up the video. It goes a long way for us, so we really appreciate it. Thank you.
Happy to participate.
Thank you.
I'm just gonna reiterate that. Thank you, guys, the NGD team. You've it's been an hour and 20 minutes. So thank you so much for taking the time, and thank you all for watching this stream. And as we said before, all the information will be in the chat below. Sorry, not in the chat, in the description below. So you'll be able to access it later as well. Thank you so much, everyone, and have a great rest of your day. And Happy New Year.
Happy New Year.
Hey.
Enjoy the coffee.